Hi, my name is Shin from Seoul National University, and I'll present the paper MRI Imputation based on fuse index and intensity registration. Before we start, I'll give a brief introduction about the background and motivations. MRI volumes are taken through several imaging sequences, and each of them are visualized through a group of two-dimensional scans. Unfortunately, many scans are often missing due to several problems. To solve these problems, many registrations, sequence translation, and imputation methods have been proposed. However, limitations still remain as they require closely related or similar data and lose either structural or visual parts. To deal with these limitations and provide a clinically useful fill-in, we propose this paper. Our method is mainly based on two ideas. The first, that is shown in this page, is adopting two registration fields in two directions. They are based on two observations that scans within the same imaging sequence show similar appearances and contrast while showing different anatomical structures. And different scans within the same scan index show similar anatomies but exhibit different appearances and contrast. The two registration fields, index registration field and intensity registration field, is proposed by those two observations. The second idea is a novel term defined as invariant registration field. Invariant registration field is registration fields that are applicable in the parallel direction regardless of imaging sequence or scan index. As shown in the right picture, two fields allow two estimates of the missing scan, one within corresponding image sequence and another along scan index, and they preserve both anatomical structure and contrast aspects. From this slide, we give formulations and details of the two registration fields and imputation process. The index registration field is similar to the conventional registration field, and a smooth index registration field phi with displacement function u is defined as the equation. An index registration field warping moving image M to fixed image F can be defined with the network F zeta IR with learnable parameters. Next, a new concept of intensity registration field is introduced for nonlinear mapping of contrast. Similar to index registration, transferred pixel intensity values with function V can be defined as the equation. Nonlinear mapping between moving image M and fixed image F can be defined with the network G zeta st with learnable parameters zeta st. Utilizing both registration fields, an imputation procedure is visualized and formulated below. Details can be shown in the poster that we post. We now show experiments and results. The first is qualitative comparison against other methods. As shown, our method improves both structural and contrast details and captures even small anatomical parts located in the center of brain. In the next quantitative comparison, we show that for every dataset and sequence transition, we outperform by all measures. Lastly, an ablation study and choice of hyperparameter is shown. For more details, please refer to our poster. Thank you for listening, and we would be thankful if you visit our poster with paper ID 558.